Okay, so what we're going to do here is we're going to graph and label the vertex, axis of symmetry, focus, directrix, and any intercepts, either x or y, for this equation. All right, so we've got y squared minus 2y minus 12x plus 13 equals 0. I'm going to move some things around so I can get to it. And how I'm going to do that is we're going to go ahead and complete the square. And I'll show you how to get that done. This one's pretty normal, completing the square one. And what I do when I complete the square on a parabola is I'll put the x and the y, or the x and the constant over on the other side if that's what you're solving for. Because notice we have a y squared, so we know we're going to be solving for x in this particular problem. So I'm going to go ahead and add 12x to the other side and subtract 13. So we're going to add 12x over here and subtract 13. And so we've added that to both sides, and so here you've got those crossed out, that's 0, that's 0. And so you'd have y squared minus 2y equals 12x minus 13. And it's important to show your work so you don't make any sign errors in this stuff. So then the next step here is I'm going to use the symmetric property to flip that across the equal sign, because I always like what I'm solving on the left. I mean, for you it could be different, but that's just the way I guess I did it as a kid, and so now I have a hard time doing anything else. So y squared minus 2y. And now we can complete the square. There's no numbers in front of the y, so or the y squared. There's no quadratic term, and so I'm going to go ahead and divide the negative 2 by 2. So I'll just do it off to the side so you can kind of see what I'm doing. So negative 2 divided by 2, and then I'm going to square that. So negative 2 divided by 2 is negative 1, but then when you square that, you get 1. So we got negative 1 squared, which is 1. So we're going to add that to both sides of the equation. So we'd have plus 1 here and plus 1 here, and that way the equation stays balanced. And so we've got then 12x minus 12 equals, and the reason we complete the square is so that this factors. So I'll go ahead and write it out. I'll try and show my work really nicely. And so this factors to minus plus is minus minus, and so it's the perfect square minus y minus 1 squared. And you know, I'm kind of skipping some steps to do that. So post a question if you're not sure that what I did just there, and I can make another video. Or look at perfect square, factoring perfect squares, and you'll see lots of those examples in what I did. So then you've got 12x minus 12. So now we're going to go ahead and solve for x. So I'll add 12 to the other side. And so I'd have 12x equals y minus 1 squared plus 12. Then I divide everything by 12. So I'm going to divide this by 12, this group of stuff by 12, and this by 12. And then, so then I would have, whoops, I went just a little too far. So then I'd have x equals y minus 1 squared, and I'm going to put that 1/12 out front, plus 1. So what that does for me then, I didn't put the general form of this down, but the general form for this particular equation is y equals a times y minus k squared plus h. So in my vertex, if you've seen this before, I mean, this video is really made for somebody who's seen this before. My vertex would be hk. And so my vertex in this case would be 1 for this one and 1 for this one. So my vertex is 1, 1. then the other part of that is the next thing I go ahead and find quickly, and then we'll start graphing this thing, is I find the focus, or the distance to the focus from the vertex. And how you find that is this A value could really be replaced with 1 over 4p, where p is the distance that the focus lies from the vertex and the distance that the directrix lies from the vertex. So I'll go ahead and set 1 over 4p equal to my A value, which is this 1/12 there. And then if you go ahead and get common denominators for this, we need a 12p for common denominator. So I need a p here. So I'm going to multiply this side by p over p. And I need a 3 over here. So I'm going to multiply this side by 3 over 3. Make sure that's right. So yeah, so you'd have 3 over 12p equals p over 12p. And then I'm going to multiply the entire equation by 12p. And what happens is 12p divided by 12p is 1 as I distribute this through. And on the other, you also do it on the other side. That's a bad way to do it with distribution. Sorry. That's it's not distribution. So I've got 3 over 12p equals p over 12p. So I'm going to multiply this side by 12p. So let me break this up. So I'm going to multiply this side by 12p, and whatever you do to the left side, you also do to the right side. So I'm going to also multiply this side by 12p. And what happens is your 12p's cross out in both cases. And so we know that p is equal to 3. And so that's the distance to my vertex, or focus. So I'll go ahead and we're going to add another page, and I'll put in a graph here. And I think we can just use this simple one. And so the first thing, so 1, 1 is my vertex. My this graph opens since we're solving for x and a is positive 1/12. It opens to the right. So my focus is here at it looks like 1, 2, 3, 4, 1. So there's my focus. My directrix is 3 the other direction, 1, 2, 3. And my axis of symmetry, and I'll do that in red, or let's do it in green. My axis of symmetry is here. So at this point, I know I'm not going to have, just kind of generally sketching this out, this is what it's going to look like when I sketch it out. I don't have any y-intercepts, but I do have an x-intercept. And so what we can do to find that, we know my equation's x equals 1/12 y minus 1 squared plus 1. And so we could go ahead and put a 0 in for y, because this, whatever point this is, that would be 0. So for the y value, we don't know what the x value is. So I'll make a table, go x and y, and I'm going to put a 0 in for y. And when you put a 0 in for y, just kind of to show my work here, so we just get a couple points, we'd have x equals 1/12 times 0 minus 1 squared plus 1. And so x equals 1/12 plus 1. So it looks like 1 and 1/12. 1 and 1/12. Okay, so you'd go right 1 and 1/12, up 0. So we're looking about right there. And then you can mirror that point across your axis of symmetry. And we probably need one more point, and it'd be nice to get one that's not quite so nasty. So I'm going to pick, well, I don't want to get off my graph, so I don't know, maybe 3, 4, maybe 4 for y. That'll get us somewhat close to something reasonable. And so 4, which will give us, so 1/12 times 4 minus 1 squared plus 1. So we'd have 3 9, so this becomes 9 times 1, 12 plus 1. And that then in turn, let me move some things over so I can slide down a little bit. And so that becomes 9/12 plus 1, and that's 3/4. So we got plus 1, so 1 3/4. So if you go right 1 3/4 and up 4, we'll get another point. So 1 3/4, 1, 2, 3, 4. And then you can mirror that up 3, down 3, 1, 2, 3. And that gives you just a general idea of what this graph looks like. If you continued it on out, you could find your latus rectum, which is the distance across your focus to the graph, but I'm not going to do that in this. That's a little bit beyond what I'm intending for this one. So that's a pretty good idea of what your graph for this particular parabola looks like. I hope this helps, and I will see you next time.